My name is Kostas, and I am the Science and Technology Manager of BonFIRE. The aim for this webinar is to explain to you the basics of how BonFIRE works and provide some more in-depth information on what functionalities you could use to make the most of it. We have divided the presentation in 5 sections. I will first describe the basic experiment lifecycle and how one operates on BonFIRE. I will then go on to describe the key functionalities that make BonFIRE the unique cloud experiment it is. I will give a brief description of the testbed sites that we've got on BonFIRE and some indication of when you should be using which one. And then I'll describe the client tools and give a very brief reference to support mechanism that is available to you. So starting with the BonFIRE experiment license, there are some things that you need to do in advance. They are either to go on the involved page and join BonFIRE through the open access scheme, or if somebody in your group has already achieved this, you need to register on BonFIRE using the second link there. And then you can go on the BonFIRE portal and upload your public key, and you can follow documentation on the BonFIRE doc page about how to upload SSH keys if you need help with this. I should say that the documentation page, of which there will be a few references in this talk, is public. You don't need to have a BonFIRE account so as to access. You can already start playing even if you don't have an account. Having done the public key upload, then you need to set up your computer for SSH. I assume that this is pretty well understood, but still we have some information, as you can see, on our documentation about this. So having done all this, you are then ready to create the experiment. There are various interfaces through which you can do this. OCCI, for which you could use curl or another tool of your choice. There is a Restfully library. There is the experiment manager of BonFIRE. There is command line tools. There is the portal. And for all of these, there is a better, more at-length description later on in this webinar. When you set up an experiment, you need to set the wall time. Now, this is a period of time after which your experiment will expire. And when that happens, your resources will be shut down, if they are VMs, and after a little while, they will be deleted. This is again described in the user documentation. But the basic interaction is the user, i.e. you, interacts with a resource manager through any of the tools that I mentioned. And they say, I want an experiment with wall time 3600 seconds. And that's what the resource manager creates. And it gives back an ID and tells you your experiment is 356. And at the moment, what you have is a container for you to start experimenting. After you've done this, you are to set up the experiment. And in doing that, you can create the BonFIRE resources. What is available is networks, compute storages, also known as, computes, also known as VMs, and storage resources. There is one particular compute resource, a VM, which is known as the Zabbix Aggregator. And if you want monitoring on your system, it makes sense to add, you have to add an aggregator. And there is a very detailed discussion about the aggregator and how to set it up. It is pretty easy, I should say, especially if you're starting from the portal, but there is a description on our website. And you'll see more examples later. So we had left it at the point where the user had created this experiment 356. And what they can do is they can create VMs as part of this experiment. And what can happen is they can shut them down or delete them, or they can start other VMs again. They can go on various sites, etc. The other thing that they can do is they can create another experiment, and this experiment has its own resources, and the resources of one experiment and the other in terms of the presentation, the XML representation are separate from each other. And to these resources, they can add data blocks, storages, save them, etc., etc., etc. After an experiment finishes, a data block that has been saved remains alive even after the experiment has finished. There is another sort of a specific mechanism called managed experiments, which I will discuss later more at length. But in that case, the user does not interact directly with the resource manager. They interact with the experiment manager. And in this case, they are expected to provide a full description of their experiment. So in this case, it has a name and it has 2 computes in it and spots the missing field. There is no wall time, and that would need to be there. But in this case, we are asking the experiment manager to organize for us the creation of 2 computes, one at EPCC and the other at INRIA, and put them on a specific network. The user puts this to the experiment manager, and in turn, the experiment manager creates a managed experiment container for itself, and then liaises with the resource manager without further user interaction to create a BonFIRE experiment and create the 2 VMs on the sites that we want them. There'll be further discussion about this later on. And what the user can do then is they can go onto their VMs and do things. So what can you do? You can log into the computes and you can configure them. It is important to bear in mind that you can save an image. You can reuse it as many times as you want in that same location, but you can't move. But the fact that you saved it on one location doesn't mean it's available on other locations. So you start, I'll show you this more graphically. What you start with on your first interaction with BonFIRE is a repository of bootable images on the 2 sites. And you can create a VM with one of these bootable images. You can then go on it. You can, for example, install MySQL using apt-get on it. You then enrich your image with the MySQL deployment. And you do a save on this. You shut down the VM, and now there is another OS image available for you. It is yours to use later. It is only available on that site, and it includes MySQL. So next time you start a VM using that image, it will include your modifications to it, like this. And then again, you need to do the same things on another site. So you may want to think about automating the way you do this kind of process. Other important aspects for BonFIRE. So taking, for example, the 3 standard cloud sites that are available, the one at EPCC in the UK, the one at INRIA in France, and the one in Germany at HLRS. When you start a VM, when you submit the request to start a VM, you can now add your own environment variable, context variable called role. And in this one, you give the value server. You could name it what you like. You could make the attribute what you like. You can name the value what you like. And then you can create another one at EPCC and you give it a different role, client. And then you give it, as part of its creation, the IP of the server VM. And then when that VM starts, the client VM starts, it knows where to go for its server. And you can do the same thing with another client with a different server IP, and so on and so forth. And you can do the same also at HLRS. And all these sites communicate with each other, and they are on the BonFIRE wide area network for this. More discussion on the network later. Some of these VMs will be shut down as part of your experiment potentially. And what you can do is you can start new VMs. You can do this interactively, or you can monitor metrics and do your own elasticity rules for this. And later on, I will describe about a feature for a manager for elasticity, so you only provide values. and it's pretty simple for you to create new VMs on the sites that you need them, either automatically or through these routines. A bit more about the connectivity. All the sites are connected through the BonFIRE wide area network, and traffic flows through that pre-configured network by default, and the VMs communicate through it. A bit now about storage. So in the previous steps you saw we created our own personalized storages, which in our case include MySQL. We can create now a VM using the operating system image, but also it includes an attached storage. And the user can configure their VM so the application data are written to that extra data block. And the user, if they want this data to persist after the end of the experiment, when, remember, everything is deleted, they need to issue a save command. And with that save command, you give the data block a name. And after the VM is shut down, the data block is still available for the user to access in a different experiment, or even in that same experiment if it's still active. So how do you access VMs? How do you personalize them? We have a system of SSH gateways and a VPN. So if you are user John Smith, you have a password on BonFIRE, which is given to you, which you upload when you do the registration process. And all this is stored in the BonFIRE LDAP server. Now, assuming that we've got three sites on the BonFIRE wide area network, and there is a VM that John Smith owns on one of the sites, the sites provide SSH gateways through which the user can SSH into their VMs. And the reason for that is that the wide area network of BonFIRE is a private network. It doesn't have public addresses. And in order to SSH from outside, you need to go through the SSH gateway. These SSH gateways are automatically populated with your public key from the BonFIRE LDAP after you upload it to the portal once. And when the VM is created for user John Smith, the public key is also inserted into the VMs, which means that they can then do an SSH from outside the BonFIRE 1, go through the SSH gateway, and end up on their VM using the credentials of the private key that corresponds to that public key. In addition to that, we have a VPN server, which also knows about user John Smith, and you can use that so as to access services running on your VM through your browser from outside. And having set up your experiment, you need to perform it. There is to be a scenario, I guess, of interactions which generate data or whatever it is that your experiment needs to do, or your set of experiments need to do, so as to prove your hypothesis and your points. There is a particular case in the case of the virtual wall. This is our emulated network site, and I will talk a little bit more about it later. In the case of the virtual wall, you need to do your initial deployment completely, then set the experiment to running, and after that, you cannot really add new VMs to the virtual wall, new compute resources to the virtual wall. You can stop using some of them. I think you can shut them down, but they are still engaged until the experiment is deleted or it expires. So this is just a nuance in the case of you using the virtual wall for emulated networks. Monitoring is important for BonFIRE. We use a Zabbix system. The Zabbix system is deployed on by default on all the VMs on BonFIRE. And if you set up a Zabbix aggregator together with your experiment, then it starts gathering monitoring data from your compute resources. Access to, because this is a VM that's running inside the BonFIRE wide area network, it doesn't have a public IP. And to facilitate access to this, we tunnel that web interface through the BonFIRE portal. And with this, system, the whole setup, you can monitor the Zabbix parameters that are already pre-configured. You can configure your own. And the important thing about BonFIRE is that it provides access to application metrics, your metrics, VM metrics, and infrastructure monitoring metrics from the same API. And I will cover this later. And you can use the monitoring API, so you can make decisions for elasticity and steer your application as you need at runtime. As I said, more on monitoring later. It's one of the very strong points of BonFIRE. And then, after your experiment has finished, you need to wrap it up. There are two ways in which it finishes. The wall time expires, or you decide to stop it or to delete it. Before this time expires, any data that you need needs to be saved. This is true for the images and for the data blocks. And then you need to shut down the VM. If you forget to shut down the VM and the expiry time arrives, you will not lose your data. Your data will automatically be saved for all the VMs and all the data blocks on which you have issued save as. That's because our system issues shutdowns anyway at the end of the wall time. So this is your little insurance policy. For all valuable data, you can save them, and at the end of the expiry time, they will be saved. This will not be true if you delete your experiment. There are no guarantees that you're going to save your data then. And there is another reference here to the experiment lifecycle. And after the experiment, what's left is the monitoring data, and there are ways in which you can get access to them after the original experiment has finished, or you can reuse the images as I showed previously. So this is what's left after an experiment has finished. Moving on now to BonFIRE key functionalities. BonFIRE is founded on 4 pillars: observability, control, advanced cloud features, and ease of use. And I will describe these at some length now. Starting with observability, we provide 3 layers of monitoring. So assume a deployment where you have 3 virtual machines, all running on the same physical machine and therefore on the same site. These virtual machines are running applications on them like MySQL, Apache, Hub Proxy, your own application like Oxadai here. And all of these have Zabbix agents deployed on them. So what you can do is you can add your application metrics into the Zabbix system and access them together with the virtual machine metrics. And so far, these things are pretty much there on most cloud sites anyway. One major distinction is that on BonFIRE you get for free 100 virtual machine metrics. And you can add others as well. You can talk to us about adding more as you need them, or you can add them as application metrics. The really groundbreaking thing is the fact that we also provide physical host infrastructure monitoring data, all through Zabbix. So at the same time, you can correlate application, VM, and physical monitoring data so as to make your decisions. So here is a graphic representation of this. We have the site at the top, which has 2 hosts. I apologize for the typo. It's VM host 1 and VM host 2. Each site is running a site aggregator which collects data from all these hosts. And we have a sort of a replication on the site here at the bottom. So what happens is BonFIRE configured agents run in the background and populate the site aggregator with live data about the status of the infrastructure. That's irrespective of whether a VM is running there or not. Then you as an experimenter start an aggregator, a Zabbix aggregator VM. In this case, we depict it with attached data. And what happens then is you create another VM with its own agent, and this generates yellow application data and puts them into the experiment aggregator. It also generates automatically, because BonFIRE is configured that way, VM data and puts them in your experiment aggregator. And the other thing that happens is that automatically, because you have started a VM on the host of the aggregator, you get you get physical infrastructure monitoring data for this host. And the same is true because you have things running on the other host, on the other site. So you get monitoring data from all the sites. And then what happens is when you shut down one of those VMs, you see that you no longer get information from the site aggregator from that host. The Zabbix GUI is very configurable, reasonably powerful. If I'm honest, its graphics capabilities could be better, but I think they do a reasonable job. I show here an example of a green metric, which is an application metric from a benchmark that we were running at the time, and a red metric, which is infrastructure monitoring data. It is data reads on bytes per second. And what happens, what we see here happening is, for some reason, my benchmarks are going down on that point around 2 p.m. And the infrastructure monitoring data show me that there is some extra disk activity on the physical host at that time. So I can correlate the fall on my disk benchmark performance against what's really happening on that VM. And we think this is a very powerful piece of functionality that you cannot get elsewhere. The red graphic is not a VM graphic. It's data from the physical host. And the 3 cloud sites on which you have access also give information about the hosts. So you can see here that there are 5 configured hosts. The 3 first are off at the moment. The other 2 are on. The first one of these, 0, has 24 running VMs. It has total 48 processors. And of these, there are only 2 available to run more things. It's pretty heavily populated. Similarly, it has 126 gigabytes of memory available for us, and what is available is 43.9, etc., etc., etc. All this is available to the BonFIRE users. And even more, when you start a VM on these sites, you provide timestamped logs which tell you at which stage your VM is. So this started on Wednesday, May the 22nd at 2 p.m. And this is its state according to the OpenNebula nomenclature. These sites all run OpenNebula. And then it moved on to Prolog, to boot, and then it went into running, and it took it about 4 minutes to do so. And all of this is available to you to access and use. And furthermore, as you create your experiment, we create a log for you, which keeps an account of what has happened. So we have an event here that as part of experiment 34260, which is the experiment we're looking at, there is a compute created at HLRS. Its ID was 12645. It was created at 12:47:44 UTC on the 22nd of May, and then another create, and then another create, and another create, and a shutdown. And all these, again, are available, and this is served from the BonFIRE portal in this case, although you can get it through a GET. Moving on to control. Observability is nice, but control is even better. And here is the opportunity to talk to you a bit about the virtual wall. So this is a special site on BonFIRE where you create computes. I keep calling them VMs, but in the case of the virtual wall, they're not really VMs. They're physical machines that you get. 4 core computers for each of those blue boxes that you see. On the virtual wall, you can set up topologies. You can create routers and switches, and you can configure the networks between them. What happens is that there is a very powerful network that links up the physical hosts that you have access to, but there is also an emulation mechanism based on Emulab, which allows you to configure user-specified networks. So computers with clever software are available to play the role of routers and create networks that you can control. So assume this topology here where you've got start from client 1 on a 10 megabit per second network and client 2 on a 10 megabit per second network with a router in between them, and then there is they fall onto a 1 gigabit per second network to a server. The server is on a 1 gigabit per second network on the other side, and then the router points to one network with 100 megabits per second, 50 millisecond latency, and 3% loss rate. And these are guaranteed because they are configured through the virtual wall. And then there is a 100 megabit per second network here, which at the moment has nothing else configured on it. So you run your application on it, potentially a streaming application, and you see that the 10 megabit per second connection just leaves you unsatisfied, whereas the 100 megabit per second latency, even with 50 millisecond latency, a 3% loss rate is good for you. And then, because you want to identify what are the limits for which your application works, what you can do is you can increase the loss rate and increase it at runtime until you find the point when this is not the case anymore. You need to run again and again the same experiment with the same conditions just to ensure that your findings are correct, but this is a very good way of doing it. The other thing you can do is you can inject traffic, background traffic. So in this case, we inject TCP traffic with 200 byte packets and a throughput of 20 packets per second. And we're still happy, and we increase to 30 packets and to 40 packets, and at that point our application breaks. So we can also study the effects of contention, network contention on your application. Control placement, going back to the cloud-based sites. So when you start a VM on BonFIRE, you have to say on which site you put it. There is no getting away from that. However, especially on BonFIRE, I don't think on any other site, you also have a view, as we said previously, of what sites or what physical hosts are available, and also what is their availability of resources on them. And you can make decisions and place your VMs where you want them. So if you say, for example, I want a light EPCC VM, then the resource manager of BonFIRE will give it to the site, and the site will decide where it ends up. There is a scheduling mechanism which decides where to put it, and at some point you may end up on the one host or the other. If, however, you specify that you want to put it specifically on VM host 1, then it will go exactly there, and you can do this as you require. Now, take this, bear this in the back of your mind as a capability. The reason why you may want to do it is already apparent in the case of sites which don't have the same kind of setup, for example. So if you look at the previous EPCC graph that I had, there were VMs that were not available, and there were physical hosts that were available and others that weren't. And the site is pretty heterogeneous. It has some boxes with 48 cores, others with 16. It has boxes with low energy chips and others which are not. And this is the case also on the site at HLRS. The site at INRIA doesn't have heterogeneous dedicated hosts, but it has on request nodes. So the 9 nodes that you see there are dedicated, but additionally there is a backend which you can reserve on which you can reserve your own dedicated resources. So you can tell it, give me 3 physical machines between those dates. The reservation system comes back to you, creates these 3 physical machines and puts them in what it calls a cluster. It gives you the handles to these. And you can say, now I want to create a VM in RIA and on that cluster, and the system will just decide based on the scheduling mechanism on which of these to schedule your new VM. Or you can say, I want it on that cluster and on that host, and you can put your VM there. And there, you are the only user executing on these physical hosts. You don't timeshare. And you take that one step further. Say you have on your cloud site 2 VMs running on 2 different hosts. However, I also have two VMs running on host 1. And you don't see what I do, and I don't see what you do. Through BonFIRE, you can tell that there are other users on it, but there's not much more you can do. Sure, you can see the impact on the infrastructure monitoring, but you cannot really see you cannot get any way of controlling it on these multi-site tests, multi-tenancy hosts. If, however, you reserve a node at INRIA, then you get exclusive access, you put your VM under test there, and then you create a special controlled contentious and malicious patterns VM, and you instruct it to inject increased memory use in the blue pattern that you see there, and at the same time increase I/O use at the pattern that you see there. And you give this to the COCOMA VM, you know what you are injecting, you are in control of that, you visualize and you get monitoring data for the effects of this on the VM, and you can deduct from this and you can deduce your own conclusions on what the effects of increased memory use and I/O use are on your system under test. Moving on to advanced features. So I spoke previously about a light VM. I didn't quite explain it. You are probably familiar from other cloud sites that you can set up VMs or with your own, with a sort of a predefined combination of CPU and memory. There are some examples here that are supported on BonFIRE. One of them in particular is custom. And in this one, you are the boss. You decide how many CPU cores and how much memory you want your VM to have. So you can create a VM of instance type custom with 16 CPUs, 16 gigabytes of memory, and put it on VM host 1 at EBCC, which supports it, and you can see from the availability that has space for it, and it gets created like that. This CPU is just an internal representation for OpenNebula. I don't worry too much about it. And then there is Elasticity as a service. I mentioned previously that it is possible for you to start and stop VMs in the duration of your experiment, or you can get them to get data from the BonFIRE aggregator or make other decisions to start and stop as they need to. In addition to that, and in conjunction with the Zabbix aggregator of your experiment, one can create a special VM that we provide, the image of whose image we provide, and you tell it where the aggregator is. You give it a metric which says when the last CPU usage that I see goes over 70%, you can give me up to 5 VMs of type light, with that image as a disk name at EBCC. And I want you to use the hub proxy load manager on port 80 at EBCC. And you see the aggregator has this view of the CPU usage metric. This is the threshold. There is a load balancer running on the same site with hub proxy already pre-configured on that. And then you start, as part of your experiment, your VM. The user accesses the load balancer and then goes on to the VM. The load is monitored. We increase the threshold, we exceed the threshold, a new VM gets spawned. We go below because of the way it is set up, it doesn't disappear. We go over it again, a new one happens. And then we go much, much lower and one of the VMs goes away. Now this is clearly a usability facility compared to the other. It's much more usable than the other elasticity options that we've got on BonFIRE. But additionally, there are clever algorithms that decide on whether a new VM should be spawned or not, which makes much more efficient the spawning and deleting of the extra VMs from the loads that you specify. Let me clarify this in case it's not clear. All these VMs here are experiment VMs that you spawn. The aggregator is yours, part of the experiment. It's your decision to start it. The Elasticity Manager and the load balancer are also yours. We provide the images, but they run on the VMs that you create as part of your experiment, same as your application VMs. Ease of use, the fourth pillar of BonFIRE. We always thought that we can do whatever clever things we like, but if it's not easy, it won't be used. Easy is very hard to interpret and misinterpret. For us, the target was experimenters like you, people who want to validate the application, the cloud application. And for this reason, we provide various interfaces, a progression through them, and documentation. So I'll cover this much later on the client tools, but the portal is probably your first starting point. Then you can move on to the experiment descriptor, which I already discussed for more detail. And then at any given time, you can go to documentation and get information. 300 pages currently and counting. It's pretty searchable and works very well, we have found. The open access sites are the virtual wall, the emulated network testbed that I described previously. There are the three cloud sites, OpenNebula, EBCC, India, and Stuttgart. And there is the cell site at Hewlett-Packard. I spoke to you about the private BonFIRE network. We also have some public connectivity over the ANT. BonFIRE is very heterogeneous. The sites have different resources between them. The sites have different resources in them. There is permanent and on-request infrastructure. The virtual wall is a very special site, and Cells is not quite the same as OpenNebula. It provides security, it provides user-defined networks at the back, it has its storages and computes, but it doesn't necessarily have the same kind of observability and control that we have on OpenNebula. If you look at capacities, HP Labs 128 cores, the virtual wall has 400, HLRS 154, EPCC 96 in the R48, and these are dedicated and available to you. You can study the setup as you need to. And on request, there are some at Hewlett-Packard, 384 cores. There is a lot at INRIA, over 1,500. And again, these are available for you to use. There is a map of the infrastructure here. The Poznan site and the Wellness Telecom site are not available to you, but you can see how things are interconnected between them, pretty much everything with everything. You can see the services that are available, and you can use the visualization feature. I'll point to it later, which is a map like this to show you whether the services are up. So if you have to decide where to use, there are different architectures. You saw the instance types defined there. Some sites define light as 0.25 rather than 0.5. These are all documented. Not all the instance types are available everywhere. Note in particular custom, which gives you a lot of freedom on the OpenNebula sites. Again, you can find all this in the documentation. If you go on the BonFIRE portal, for example, to start your VM, you will find that it will only serve you the instance types that are available to you. So, still on which site to use, it depends on your requirements, what you want to do. Control networks are only available at the virtual wall. The public IPs are available everywhere except for iMinded HLRS. Reservation of nodes through the interface that I showed graphically before is available at INRIA, and this is the URL for you to follow so as to do a reservation. I spoke about SSH and VPN before, and I spoke about the gateway as well. The visualization is available from the link that is available on the slides that you've got, and that's for this you need to be on the BonFIRE. You need to be a BonFIRE user to access it. There are log files that you saw. The OpenNebula status is available in the virtual machines. The experiment manager log, and you can get information about the status through the mailing list of BonFIRE. The key interface that BonFIRE provides is an OCCI interface on the resource manager. Everything else is a client to that. Even the interfaces that we provide are clients to the resource manager of BonFIRE. At the back of it, there is an actor component which talks to the various sites and abstracts some of the differences between them that you may not want to see. The OCCI interface that we have adopted and extended, it has to be said, to provide the extra functionality that we are about, is a RESTful interface. You can use curl or another tool to send XML, but really you don't have to. There are other client tools, and this is the point of this discussion. So there is a BonFIRE Portal, which is a web interface, and it's a starting point. The experiment descriptors, that give you managed experiments, and you can use JSON or ODF to do this. There is a special facility on the portal which lets you build your experiment descriptor, and then you can save it, edit, and resubmit. Restfully is a general purpose library. It is RESTful. You can do Ruby scripting, or you can do Ruby cells, and this interacts with the BonFIRE API. And then there are command line tools which are interactive, and you can do manual interaction as you need it to do quick queries and additions to your experiments, or to script your interaction using a shell scripting of some sort. Starting with the portal, this is how you create an experiment. You give it a name, a description, which is for you, and the wall time. Groups is something that I haven't covered, but this is a facility for you to share your experiments with other people in your team. In this case, there's a decision to create an aggregator in EaaS, and we want to have infrastructure metrics that I covered before, and we want to get information from the aggregator. And if I have ticked on this box, then you would have the Elasticity as well, which would create for you the load balancer and the other VMs that you need for that. It's step-by-step. It's a wizard. It exposes some of the functionality here. For example, are what you do after an experiment. You can create a VM, the instance types, the hosts, etc. And then after you have created them, it visualizes your deployment for you. So in this case, we have some storage in EaaS, and we have a VM in EaaS and another VM in EaaS. This one is the aggregator, as you can see from the image. These are the IPs for this, so you can SSH into them. The portal checks for you that SSH is working on this, and it gives you information about the state at a glance. Then you can click on monitoring. These are the events that I discussed before, and you can click on Open Aggregator interface, which lets you into Zabbix. And you go from portal to monitoring. So here are some benchmarks, some graphs that people have created, just to demonstrate what one can do. This uses Kokoma, for example, and shows the free memory on the box and how it drops another coordinated graphs. So these are four monitoring graphs on the one slide here. So why would one want to use this? It's a great starting point. It's very easy to use. It's very intuitive, and it gives you the experiment visualization. And if you want to set up a large-scale experiment, you have to do everything n times, n being the number of resources that you need. And each resource is created manually with a method that I sort of highlighted when I showed you that VM setup view. And you can't do scripting on this. You cannot interact with services after a deployment, etc. It's a very basic tool. But you can go on to the experiment descriptors and specify all your initial deployment of your resources, save that, and use it again. And as part of it, you can add and script effectively your contextualization of VMs. That's the addition of environment variables, as I said before. It does IP dependency resolution, so you give symbolic names to the servers that you want, and the IP is substituted for you. And also, the deployment order is decided for you. So if you have a client that relies on a server, the experiment manager will deploy the server first so as to get the IP address, and then will do the client for you. And you can configure monitoring metrics as part of the context as well. You have JSON and OVF representations. This is using the portal to create an experiment descriptor. In this case, we see what has been created. It's, you can see the format of this. It has a name, a description, much like an experiment, duration in minutes in this case. And we'll create a storage with that name in RIA. It's a data block of this size, etc. And at the bottom, in this stage, we have created other things, and you can see them further low. So these are the things you've already configured on the builder, and it says there's going to be a VM at INRIA as well, which uses storage and a network. And so here it is again, in case the other one was too small. I'm not going to go through it, but the important point is, with this one, you can say, here's an experiment and I want 1 compute, and you can revise your decision and say, no, really, I want 20. And just by making this change, you go from having a small-scale test deployment to a large-scale deployment on that same site. So much better for large-scale deployment of resources. And the builders are wonderful, I think, especially if you don't like editing JSON. It was created for BonFIRE. The experiment descriptor is purpose-built for cloud testing. And you can submit it via the portal or through a command line. Many people have actually written scripts, many of the previous experiments of BonFIRE that use the experiment descriptor in various ways. With the experiment descriptor, one cannot do any control past the end of the deployment, and you cannot do connection to the resources. You cannot do SSH as part of it or anything like that. So to do this, you can go and use Restfully, which is a library for RESTful APIs like the BonFIRE API, and it hides all the HTTP requests for you. You can do runtime discovery of resources. You can use it as a script. You can so you can use it as a shell to query the API using that kind of syntax, or you can create your own script. So here is an example of using it from a shell. You type pp root.locations and you get some information about what is available, what locations the BonFIRE API, the resource manager, knows about. Or you can write your scripts and you can say, create a new session, Ruby session. This is where my configuration file is. This is where people hide their credentials. This is the SSH gateway, which we're going to use later on. And this is where my keys are. And then I'm hiding something here. I'll come back to it. In a general case, you do create an experiment, submit experiments, call it demo SSH. This is the description. And this is the wall time that I expect, 8 hours. In this case, you can also do something like look to see if an experiment with that same name is there. And instead of starting a new one, just grab that as your experiment and continue from that point on. So very powerful, as I showed with a very simple example here. Again, Restfully is very good for large-scale experiments. You get the opportunity to install software as part of it, to SSH into it through your scripts, and you can do interactive scripts as well and decide on when to start new resources sort of interactively. There is no builder for it. I don't know how familiar we are with Ruby. We provide a few experiments, a few examples online. And you need to, it is very powerful, but on the other hand, you need to do your IP resolution, your IP dependencies, I meant, the order of execution yourself. And the command line tools, again, designed for BonFIRE and written in Python. It's pretty easy to see how to execute this from our documentation. It provides functionality for the experiment, the compute, the storage, the network, all the things that BonFIRE supports. and you can do abbreviations. You can call the whole network as 42 if it's unambiguous. You go and resolve it. So to create an experiment, one uses the bf experiment create command, which takes a name and optionally a description, a wall time, and the group to do it. So here's an example. And then you can create a storage by bf storage create. You have to give it a name and a location. You may want to add it to an experiment or may not want to add it to an experiment. If you don't add it to an experiment, it outlives experiments. Oops, excuse me, I didn't do that. And you give it a size, etc. So here's an example where you create a storage in RIA on experiment 42 with size 1024, and it's a data block, and it goes under the group BonFIRE. So they're reasonably intuitive to use. You can script them on whatever environment you've got, but scripting is more limited than Restfully, and not as user-friendly as Ruby if you know Ruby. And it's less declarative than an experiment descriptor. Again, you have to resolve the order and decide for yourself how you do this. So there are lots and lots of documentation on this on the client tools on the doc. Well, I've only got one slide then on experiment support. Lots about BonFIRE on the BonFIRE site. The user documentation, you can get it from that or from any of the other links in the slides that you were given. There is a user forum for you to pose questions. They tend to get picked up pretty quickly, or you can use the support ticketing system by emailing that address.